Good morning and welcome to Friday's maths lesson. We're sticking with volume today. We're going to recap what we did yesterday and have a look at some word problems. I must say I was very impressed with your work. You seem to have really cracked that. Really well done. So we'll start off just by recapping what we learned yesterday. To find the volume of a solid, a cuboid, you need to do width times length times height, or length times width times height. As we learnt yesterday, it doesn't matter which order you multiply these numbers in. So on the next page, there are 3 problems. Stop the video, get your pen and paper, and see if you can use this formula to find out the missing parts. So a little hint here, this is a cube. So you only need to know one of the measurements. How did you get on? Well, this is a cube, so if it's 5 centimetres high, it must be 5 centimetres long and 5 centimetres wide. 5 times 5 is 25, and 5 times 25 is 125 centimetre cubed. Did you remember your units? For this one, we need to multiply 6 times 8 times 3. 6 times 8 is 48, and 3 times 48 is 144 centimetre cubed. And the last one, you were given the volume, you were given the height, and you were given the length, and you had to work out the width. So if I know that 10 times 3 is 30, what do I multiply 30 by to get to 60? And that would be 2. So here, you're just looking for 2 centimetres. Now, have a look at these 2 3D shapes. What is the same and what is different? Stop the video. Have a little think. You might need to do some working out as well. So, well, for a start, this is a cuboid and this one's a cube. This one has all the edges the same length. On this one, the edges are not the same length. On this shape, all the faces are a square. On this shape, all the faces are rectangles. Did anybody work out the volume of these 2 shapes? If you didn't, stop the video and see if you can calculate it now. Did you spot that both of these shapes are built from the same number of cubes? They both have the same volume, which is 64 centimetre cubed. So this shows us that we can have 64 cubes and we can make different shapes with them. Which brings me on to the next question. Now, for this activity, I want you to imagine you've got 36 small cubes. And if you do have little building cubes at home, now is the time to go and get them, because this will make this exercise a lot easier. And I want you to think how many different cuboids you could build using those 36 cubes. If you don't have cubes, then one way to look at this problem is to make yourself a little chart, because you're looking for a length times a width times a height that makes 36. So you want 3 numbers that multiplied together make 36. Let me get you going with some easy ones. So, I always like to start where it's easiest. The length could be 1, the width could be 1, and therefore the height would have to be 36. Whoops, we've already lost our length. That would be one possibility. Or you could have a length of 1, a height of 2, sorry, a width of 2, which would mean you'd have to have a height of 18. 1 times 2 is 2, 2 times 18 are 36. Remember, these three numbers multiplied together must equal 36. Now, let's carry on with a length of 1. This time I'll have a width of 3. 1 times 3 is 3, so this is going to have to be a height of 12. 1 times 3 is 3, and 3 times 12 is 36. My suggestion is you stick with 1 and maybe try a width of 4. And stick with a length of 1 and maybe try a width of 6. Stop the video and see how many different cuboids you could build with 36 cubes, finding 3 numbers that multiply to make 36. How far did you get? Apparently, with 36 cubes, you could make 54 different cuboids. I didn't quite get that far, but it would take you a long time to work that out. So if you work systematically, you may have nearly got there. Right. Let's have a look at the next problem. Now, we've got 2 shapes here. There's a cube, there's a cuboid. We are told that both of these shapes have the same volume. They take up the same amount of space. What we are asked to do is calculate the missing length here. What I'd like you to do is stop the video and have a thought. This is a multi-step problem. Where would you start if you wish to find the missing length here? Well, the place to start is the cube. You need to know what the volume of these 2 cuboids are, the cube and the cuboid. They're the same volume, and you know that this cube has an edge that measures 4. So to find the volume, we need to do 4 times 4 times 4, which is 64 centimetres cubed. So if you know that the cube is 64 centimetres cubed, then the cuboid must also be 64 centimetres cubed. Now, what do we know? Well, we know that we can multiply the 2 times the floor, which is 8. What do we multiply 8 by to get to 64? We have to multiply it by another 8 because 8 times 8 is 64. So we now know that the missing side must be 8 centimetres long. On the next page are some very similar problems. What you need to do is start by working out the volume of the cube. You then know that the cuboid has that volume, and you can work out the missing edge. Off you go, stop the video. Okay, let's see how you got on. So, start here. The volume is going to be 2 times 2 times 2. 2 times 2 is 4, and 2 times 4 is 8. So the volume of that cube is 8 centimetre cubed. So therefore the volume of this must also be 8 centimetre cubed. We know it's 1 times 2, height times width. So 1 times 2 is 2. What do you multiply 2 by to get to 8? The missing edge must be 4. Okay. You need to approach this one in exactly the same way. We need to work out the volume of the cube. 6 times 6 times 6. 6 times 6 is 36. 6 times 36 is 216. So the volume of that is 216 centimetre cubed, which is also the volume of this one. So if we do 4 times 6 is 24. You perhaps need to work this out on a piece of paper, but you need to know how many 24s there are in 216. And there are, in fact, 9. So the missing the missing edge on this cuboid is 9 centimetres long. A couple of tricky problems there. Now, I'd like you to have a look at the nets of these 3D shapes. One of these is a net of a cube, and one of these is a net of a cuboid. In case you've forgotten what a net is, if you cut round the edge and folded these up, they would be a cube or a cuboid. The net is if you'd unfolded a shape. This is if you were making it out of paper, you'd have to cut this shape out and fold it along the lines. You've probably recognised that this one would be the net of a cube, and we know this is the cube because all the edges are the same length. This is the cuboid because we can see that the edges are different lengths. The faces on the cuboid are rectangles, the faces on the cube are squares. So if you know that, this is a net of a cuboid. How could you use that net to work out the volume of that cuboid if you cut it out and made it back into the cuboid shape? Stop the video and have a think. Is there a way of working it out? Well, let's look at that net there. I know that one of the measurements will be 3 centimetres, another of the measurements will be 2 centimetres, and the third measurement will be 2 centimetres. So the length, the width and the height, 3, 2 and 2. It doesn't matter which order you do it in. So to work out the volume, we've got to do 3 times 2, which is 6, and 6 times 2, which is 12. So from that net, we can work out that the volume of this cuboid is 12 centimetre cube. One final piece of teaching today. So the last thing I'm going to talk about is surface area. Now, what I want you to do is forget about volume because we're now on to area. Remember, volume is the space that a shape takes up. Area is 2D. So when we talk about the surface area of a cuboid, I like to imagine, to calculate that, if I was wrapping this up in paper, how much paper would I need to cover all of the surface of that cuboid? How much paper would cover each of the 6 faces on that cuboid? To work out the surface area, you can either try and visualise in your head. If you've got a face with 4 blocks this side, there'll be 4 blocks the other side. If there's 6 this side, there'll be 6 that side. And if there's 6 on top, there'll be 6 underneath. Or what you could do is try and draw the net of that shape. Here we go. If we were able to unfold that cube, it would end up as the exact same net that we saw in the previous problem. And from this, we can then calculate the surface area. So this surface has 6 square centimetres, and there's 4 surfaces exactly the same, 4 faces the same. So 4 times 6 is 24. Then we have to add on the 4 here, that's 28, and another 4 here, which would be 32. So the surface area of that cube would be 32 centimetres squared this time, because we're talking about area. Now you see why I've put this in the volume teaching on the next slide. Can you work out the surface area of these cuboids here? Got one that side and one that side. See if you can visualise what each of the 6 faces would look like and how many square centimetres each one would be. It might help if you were able to draw the net of these shapes. Off you go, stop the video. So, let's have a look at this cuboid first, well I can see that this face here has 3 by 4, so this must have 12 centimetres squared there. And I know that the opposite face to that will also have 12, so that will be 12 times 2, which is 24 centimetres squared. I'm then going to look at this face here, which is 2 times 3, so that will be 6 centimetres squared. And the bottom face will mirror that face, so there must be 2 of those. That will be 12 centimetres squared. And finally we'll look at this face here, which is 2 times 4, so that's 8 centimetres squared, and that will have a matching face at the back, times 2, so that's 16 centimetres squared. I now just need to add up the 6 faces to find the total surface area. 6 and 4 is 10, 2, 2, 3, 4, 5, 52. So the total surface area of that cuboid is 52 centimetres squared. So that is how much paper you would need if you wanted to cover the whole of the cuboid. The other cube is very easy because it's a cube. So we know that each face has 4 centimetres squared on it, and there are 6 faces. So the surface area would simply be 6 times 4, which is 24 centimetres squared. Okay, if you head over to Google Classroom now, you will find some activities to help you practice what you've learned today. We'll be going over finding volume, putting volume into word problems, and you might get onto a couple of surface area problems too. Remember, the spicy is the sort of entry level, hot a little bit more challenging, and very hot, they are very challenging questions. Again, if you're struggling to type into the worksheets on Google Classroom, either write it on a piece of paper and send me a photograph, or you can try just going to beneath where all the questions are and just write your answers at the bottom of the question sheet. Good luck!